In example 7, we're asked to find the arc length, and arc length is a fraction of the circle's circumference, just how sector area is a fraction of the circle's area. So we're following a very similar equation to what we did for sector area, but instead of pi r squared for our area equation, we're using 2 pi r as our radius version of a circumference equation, and then just multiply it by the fraction of the circle that we have, represented either by the arc measure or the central angle. And make sure that you're not confusing arc measure with arc length. They're two different measures that pertain to that circle. So in example 7, we're given a circle with a radius of 8 centimeters and an arc FG of 134 degrees. So to find this arc length, go 2 pi times the radius of 8 and multiply this by our fraction of the circle that we have, 134 out of 360 degrees. And we could simplify this a little bit. We know that 16 pi would be our full circumference. And we're going to multiply it by this fraction. Not a obvious fraction to simplify. They're both even numbers, so obviously we could reduce that a little bit, but let's just let the calculator take care of this and multiply it by the 16. And in this case, we get a repeating decimal. It is a rational number, and we could represent this as a fraction if we wanted to for our answer in terms of pi, but we'll use the Repeten bar. 5.95 repeating pi centimeters would be the exact answer. To have our answer rounded to the nearest hundredth, let's take that exact answer that's still in our calculator and multiply it by pi, and we get a rounded answer, about 18.71 centimeters.